Hello everybody, my name is John Vogtman. I'm a water quality engineer at the Philadelphia Water Department, and for this part of the presentation I'm going to focus on PWD's experience with using BlueBox as our event detection software, and more specifically focus on a case study in which we use BlueBox to monitor 4 of our online water quality monitoring sites. Alright, so here's a brief outline of what I'm going to go over today. I'm going to start with the goals and the objectives of the project. I'm going to then talk about how we selected our initial stations, briefly go through the implementation, discuss the results of the study, talk about how we're currently using BlueBox, our future plans with it, and then go through some screenshots and example alarms. So our main goal was to minimize the number of false alarms while also minimizing the risk of missing any true alarms. And this is one of the biggest EDS challenges, is making the system sensitive enough to pick up on as many true alarms as possible without having an overwhelming number of false alarms. Additionally, we wanted to maximize system reliability and usability. So those were our 3 main goals and objectives. Okay, so initially we chose 3 locations that were hydraulically connected. Those are stations A, B, and C on that diagram. And then we later added site D. We monitor total chlorine residual, oxidation reduction potential, conductivity, pressure, temperature, and turbidity at each one of these stations. And these 4 stations had the dual purpose of benefiting both PWD and Whitewater. Whitewater was interested in studying how hydraulically connected stations were affected by upstream events, and PWD was more interested in seeing how BlueBox would work on a variety of different stations. So as you can see from the diagram, Station A is a pumping station that's just outside of a treatment plant. Station C is a representative location within our distribution system. Station B is the influent to one of our reservoirs. And Station D, Station D is the effluent to that reservoir. Station D is kind of interesting because there's actually 2 influents to the reservoir. So it monitors a mixture of our 2 sources. Okay, for the implementation, the project began with PWD providing approximately a year's worth of historical data to Whitewater. Whitewater then ran statistical analysis on the individual sensors and submodels to do initial calibration for each site. And during this process, we had weekly conference calls and discussed the progress. Following that, the system was installed at PWD. This was about a 4-day process. They installed the software, integrated with SCADA, and gave us some basic training. And once the system was installed, PWD began classifying the alarms and working with Whitewater to fine-tune the software. The fine-tuning software process was, I would say, generally 3 to 4 weeks. But even after that, results continued to improve in subsequent months as more alarms came up and additional settings were tweaked. And just to give you like an initial time frame on things, the initial stations were installed within about 4 months of the trigger date, and then adding additional sites after the initial installation is generally quicker, and sites are just installed in a matter of hours through a WebEx session, and the fine-tuning generally takes a little bit less, maybe like 2 to 3 weeks once you get that initial installation done. As far as the results go, once the system was fine-tuned, standard deviations were tweaked, the initial alarms were classified, etc. We saw a definite improvement in the true and false alarm ratios. There's no visible increase in false negatives. This is hard to say for sure since we don't have someone constantly monitoring for events and checking to see, if BlueBox missed anything, we can easily see false alarms, but it's hard to see, if there was something that happened that it didn't alarm on. So that's something I plan on looking into in the future. There was minimal system downtime. I would say most of the downtime was related to our SCADA system and not BlueBox at all. The software is intuitive. It's generally easy to use. It has a nice graphical user interface and a built-in graphing function that's really useful in quickly identifying and classifying alarms. The staff is also very helpful and knowledgeable. They've conducted multiple site visits, conducted WebEx sessions, and have great response time to questions by phone or email. Okay, so currently we're moving on from our initial 4 pilot project locations to 5 contamination warning system locations. We're having 2 to 4 WebEx sessions per week to fine-tune and calibrate the sites. We're also expanding the project by integrating BlueBox to our dashboard and whiskey products. The dashboard is a site that various people within the water department have access to and can view real-time alerts as they occur in BlueBox, as well as all our other components like customer complaints, security monitoring, and grab sample analysis. For the future, we plan on adding the remaining 5 CWS sites. We also eventually hope to expand to all of our 37 online water quality monitoring sites. I'd also like to start utilizing a reporting feature that Whitewater has to kind of, it can compare the number of alarms at different sites, the number of alarms for different submodels, and can kind of help you figure out, what needs to be tweaked within the software. If one submodel might be alarming more than another. It also is a good tool to be able to send out to managers or, other people within the department to kind of get an idea of what's going on with the alarms. And then, as I was saying before, I also want to kind of start investigating BlueBox effectiveness in minimizing the false positives. Okay, so I'm going to move on to some screenshots here, some events that have occurred. This is an example of one of the flushing events that we had to define as user-defined. But basically, another unit within the water department started a flushing and sampling program at one of our sites, and they didn't tell us about it. And for a week or two, we started getting alarms from BlueBox every Wednesday with the same kind of pattern. It's kind of like a drop in pressure, a spike in turbidity, and a decrease in chlorine. So when this started happening, we started investigating it, and we found that they were opening a valve on our sample line to collect the sample and letting it run for about an hour or so, which was resulting in this turbidity spike and drop in chlorine and drop in pressure. Here's an example of a sensor malfunction. BlueBox detected multiple blips in the conductivity sensor that resulted in expedited maintenance, basically. The top right screen shot shows some model noise exceeding the limit multiple times, which resulted in an alarm. And then the bottom left shows the 3 parameters, including conductivity, which was responsible for this alarm. I guess also with this slide, we also detected a couple times where electrolyte would leak out of our chlorine sensors. So, all of a sudden chlorine would drop down. Like we have redundant chlorine sensors. So one of the chlorine sensors would all of a sudden drop down to almost 0. And BlueBox was very effective in identifying that and allowing us to put it back online as quickly as possible. And then here's just a good example of a turbidity spike. You can see the turbidity in green there and the chlorine in red. As the turbidity spikes up to 4, the chlorine also drops accordingly. And that's basically all I have. This is my contact information. If anyone doesn't get a chance to ask me a question in the question and answer session, feel free to call me. My number is 215-685-1460, or contact me by email at john.vogtman@phila.gov.